Next up, we have the story about the Deliverect with my colleague Sven, who is head of data, and for sure Antonio, technical lead for data at Deliverect, and they will tell you about a strategy for a modern data architecture. Sven, Antonio.
Thank you. All right, thank you all for joining. So indeed, we'll talk about how to build a scalable and agile modern data architecture using the modern data stack. And then we'll deep dive a bit into the story of Deliverect, what was their journey over the past 5 to 6 years, and their lessons learned. So let's start with some numbers. Over the past 10 years, over the past 8 years, we've seen the data has been growing 10 times in that period. Now we expect that in 3 years there will be 175 zettabytes of data being generated by all organizations. So this is pretty huge. But we see that only 68% of companies are actually 68% of companies are actually unable to realize tangible and measurable value out of that data. So what should a data platform look like, and how can technology and Google Cloud help you to be able to get value out of your data? And so next to the business and data strategy, also what about the architecture? Because Peter Winkelmans was talking about, okay, build versus buy. There are certain solutions on the market where you can have like an off-the-shelf CDP to get interesting analytics out of your marketing data. But if you really want to get the full potential out of your data, you need to build. But to be able to build, you need to write building blocks. But there are a lot of building blocks these days. So many different services and solutions that help you get the right value out of your data. So that's a bit the purpose of this session, is to guide you a bit in, okay, what are actually the essential components data architecture should have, and to give a bit of our recommendations as Devoteam G Cloud, the tooling we like to work with, to be able to, so that you don't have to analyze every single thing yourself. So the modern data architecture, if you look, okay, on the left side, you have your data sources and your applications, whether those are the data sources, whether those are databases or streaming data sources, whether you have to pull, push, it's all a bit high level today. But on the right side here, this is mostly, okay, what do we want to get out of that data? So we have the insights. You want to have dashboards and BI, but you also want to go further and be able to activate based on that data. You have the smart analytics, where you have all those different data sources. You want to find patterns between them, or you want to be able to predict the future. But also the third one here, the applications. So everyone is using applications in their business processes and daily work. You want to be able to leverage all the power and knowledge of that data inside the applications that you work with to make your business processes more efficient, etc. So we'll touch upon, and then in the middle there are all those different building blocks that we'll touch one by one. So let's start with the data lakehouse. Now, this is maybe a bit of a new term, right? So if we look a bit back in history, first we talked about data warehouses. So organizations started to understand, okay, we need to bring data in one place, and we need to be able to query it using SQL engines like Teradata and Netezza SQL Server. Those were usually on-premise. But then more data became, we started to collect more and more data in many different formats, and it was just not possible to get it all nice and structured into a data warehouse. So we started building huge data lakes. Just dump it all in there in the raw data, and then the data scientists are tech savvy enough to get the data that they need and start building machine learning models and everything. But now, in 2022, actually, we want to get the best out of the data lake and the best out of the data warehouse. And we have a new term that's come up, the data lakehouse. So who has heard of BigQuery before? Google Cloud BigQuery, okay. Who has heard of Big Lake? Okay, that's almost going from 100% to 5%. So this is Big Lake, right? From Google, and you don't need to Basically, what BigLake allows you to do is that you don't need to put everything anymore in your data warehouse. BigLake is able to query your data in BigQuery, but you can also query data sitting in cloud storage, or even from other clouds. You can query your data sitting in S3 or Azure without having to move your data. It's basically understands and has this storage engine and abstracts away where the data is actually located, and it lets you manage things like row level security, etc., all in one central layer instead of having to worry about that in every single place where your data is stored. It can even work on top of unstructured data. So now from BigLake you can query the metadata of your images, for example, all without having to move things or create data pipelines. So that is actually usually the heart of our data warehouse. It's BigQuery and BigLake that allow us to have our data stored and ingested. But still, you need to get your data from your applications and your data sources into one of those things, right? You need to have it in S3 or in cloud storage or in BigQuery. So this is the data ingestion layer that we need. And here, if you look, for example, okay, I need to get Facebook ads data into BigQuery, you'll find hundreds of different solutions that can do that for you. So our recommendation is as follows. If there is a Google native connector, just use it, right? You have the storage transfer service, you have the BigQuery data transfer service, especially you have like Google tooling like YouTube, Google Ads. I mean, it's just one click and your data is streaming into BigQuery. Then you have a bunch of popular data sources that are not, that there's no Google native connector for. And then the question is, okay, what if I develop it myself? It's not that hard, right? I can have, I mean, they have Facebook ads, for example, they have a nice API. I can develop a custom pipeline myself, but then you really need to start balancing those things. Okay, what about the development of it, the maintenance of it, and versus the cost of just buying it through Fivetran, for example, one of our trusted partners. Because you don't want to spend all your engineering time into writing data pipelines, right? You want to have your data and start getting value out of it. You don't want to spend too much time into moving it. So our recommendation is usually if there's like a native connector like Fivetran, just use it and then try to balance that. And then there are also some more niche connectors that there is no connector available for on the market. And then so if you have to go in that development mode, then use a framework. For example, Airbyte is open source, and they have hundreds of connectors just on the GitHub repository, where many engineers have done it before you, and then there are like the different connect, like if you need to connect to an OAuth 2 API, etc., you can just reuse what all the developers did and go much faster and quicker because there's rich documentation and etc. So that is that. Then once you have your raw data into your BigLake or BigQuery, then the purpose is to model it and to be able to provide it in the correct format to then get value out of it. Now, to do those transformations, there are many ways you can do that. You can write Apache Beam pipelines, etc., etc. But usually, just stick to SQL. I think 50% of all tech guys is able to write and understand SQL. Leverage it because we have things like BigQuery can handle semi-structured data like JSON, etc. And you can go pretty far in SQL. If you can even call cloud functions within your BigQuery SQL to do some, to call an API in between, etc., etc. So if you want to work with SQL orchestration, you have two main options in the market. You have Dataform and you have dbt. They both have an open source core, so you can deep dive into it and understand how it's working and even extend it. They both allow you to do templating of your SQL and to be able to generate it. Dataform is using JavaScript, dbt is using Jinja. If you look at the hosting, so Dataform is simply integrated within the Google Cloud Console. You create your first BigQuery table, and on the left side you see Dataform where you can start writing your SQL transformations. If you use dbt, then you need to either host it yourself using, for example, Cloud Run, combined with a cloud scheduler and cloud workflows, for example, or you use dbt Cloud, which is a paid solution, SaaS solution. Now, looking then at the access, Dataform being integrated within Google, is pretty convenient and secure, because you're using the Google Cloud IAM, etc. service accounts to be able to query your data. If you go for something like dbt Cloud, then you need to have like one master service account that can query all of your data and have it in a separate SaaS solution. So that's maybe something to think about. And then the community. So the dbt definitely has the largest community. So there you can leverage the macros and packages and many add-ons that have been developed by the community. Dataform is growing. There are also, because you also have those JavaScript packages within. So it's a bit of a balance to make, like, do you go for a Google native integrated, or do you go for a larger community? That depends a bit on the organization. Then you have BI. And there are two main challenges that organizations are facing. One is the bottleneck. Right? So you have a data team, they create a dashboard, and then business users are looking at that dashboard, but that's not where it stops, right? Once you look at the dashboard and you see a number in red, for example, you want to know why. So then you have to ask additional questions. And like this, so many questions are just piling up because the central data team cannot handle it. The second issue is chaos. If you have to ask in your organizations how many customers you have, if you ask the questions to the marketing team or to the sales team, you very often have a different answer. So the way that Google likes to tackle it is by having a bit of a different architecture than usual BI platforms. If you look at traditional BI tools, you have usually you have your database, and you need to extract data out of it to be able to provide a cube, and that cube serves a particular use case and is then fast and performant. But then in the end, you end up with like 14 different cubes where the definition of customer might be different in one than in the other. The way that Looker handles it is by having a direct connection to your BigQuery database. And this allows you to leverage like the full investment you're doing in your data warehouse. So in Looker, you model how your data warehouse looks like, and one dashboard is just one angle. And then from that angle, you can explore, keep exploring and keep drilling down and going further into your database. Because you have this entire data warehouse modeled, and really allows you to have this self-service analytics capabilities that you want to achieve. Then you have AI, right? And AI, I mean, Google has always been at the forefront of AI. I mean, not many people maybe know that in ChatGPT, the T actually comes from transformer, which was invented by Google in 2017. And you have different options at Google. So on one hand, you have the out-of-the-box solutions, like just give an image to Google and they'll tell you what is on that image. In the middle here, you can have a bit of a combination. You can leverage all the models from Google, but train them with your own data. And Google makes it even so convenient that you can use SQL, right? Instead of saying create or replace table, you say create or replace machine learning model. Or if you want to predict the future, you don't say select star, because that looks at what you have. You just say select ml.predict. And this suddenly gives you so much power, and you don't need to have a bunch of data scientists. You just need someone that can write SQL to be able to leverage Google's machine learning models trained on your own data. And then you have the do-it-yourself, where you go into the full, where you're using TensorFlow pipelines or Kubeflow, and you have the MLOps pipelines to bring it to production, but we have more ML-savvy guys to talk about that. Then we have the reverse ETL. So what I mentioned before, right? You want to be able, for example, to use your data into tools like Salesforce. You want to enrich your CRM data with customer lifetime value of that customer, for example. Or you want to be able to send targeted campaigns on HubSpot or Facebook using basically the data that you have. Or the thing is with the data platform like BigQuery, BigQuery is very good in handling very large queries. But if you want very quick response times and being able to get, for example, the answers from a recommender system in real time for a particular customer, then you need to transfer that data first into a performant database like a NoSQL. So reverse ETL helps you in doing that and helps you in moving data from your data warehouse into an application database or third-party integration. So 3 very easy steps. You connect your source, your destination. You select which table or combination of tables to use with a certain set of filters, attributes. For example, here we have like the recent female adult buyers is a segment we created on top of our BigQuery model. And then you just need to map how it should map to the fields available in the Salesforce API, for example. We map our email column to the email address column in Salesforce. And like this, we suddenly are enriching our application with the data that we got from our data warehouse. Then we have the governance layer. So having all of this data is nice, and we get value out of it, but you need to make sure to keep it secure, to think of privacy, to be able to govern it, that it doesn't become the Wild West. So this is what basically what Google Cloud offers, and it's Google Cloud Dataplex. And it's a unified data management layer on top of your BigQuery cloud storage or even OLTP databases to be able to do quality checks or data profiling or to define the lineage, to create a data catalog next to a business glossary, right? So this is what Dataplex offers. However, Dataplex is still, let's say, a bit too technical, so it allows you to be able to configure the quality rules and everything you need to. But for business end users, it's maybe not the most friendly tool. So then you can look at other tools like Collibra, Zinea, that offer like more of a business-friendly experience. But we also see that people often know that, okay, or that organizations know, okay, I need this. I need to be able to have better data governance. But the tool won't offer you that. You first need to go through this organizational change where you have to change your processes and where you have to define and move, for example, ownership of data away from the central data team into your different domains within your organization, for example. So don't go and buy an expensive data governance tool. First, try to think and remodel your processes and people. And then, last but not least, the orchestration. So you have all those different building blocks, but you need to stitch them together to orchestrate it and to basically have a fluent pipeline going from ingestion to transformations to reverse ETL, etc., etc. And so also here, 2 options. So I think the most common one to use is Cloud Composer. Cloud Composer is, you're able to orchestrate very complex pipelines in a declarative manner. So it automatically finds dependencies between steps, etc. You can have high complexity. You can include bash operators, Kubernetes pod operators, etc., with operators and sensors. But on the other side, what we're pretty often using these days is actually Cloud Workflows. Cloud Workflows is very lightweight. The only thing you need to do is you need to create a YAML file and say, okay, first trigger my ingestion process, then please run my Dataform pipeline, and then start my reverse ETL processes. And the only thing you need to do is have a small YAML script, and then you have also a visual representation of your pipeline, and then you can schedule it with Cloud Scheduler. And there's no need anymore to pay $300 a month for one Cloud Composer cluster and to have management of that. So if you are starting small or you don't have too complex things, or basically the complexity is embedded into your dbt step, for example, then Cloud Workflows might be interesting for you. So that's the full picture. Then let's just finish off with a small conclusion. Conclusion, just leverage the wide ecosystem of Google and all the data and AI services that it provides. It goes so fast. Every day there's something new in the release notes that will help you accelerate and improve your journey. Then keep it simple, stupid. Don't reinvent the wheel. Don't go and build a data connector that is already available. So use frameworks, open source or paid solutions to make you go faster. Make sure to balance development and maintenance of new solutions, like the build versus buy, as Peter Winkelmans was saying. Don't be too dependent on tooling, because we were mentioning also vendor lock-in before. So Google has a pretty open architecture. If you look at a Cloud Composer, Dataform, etc., they're all based on open source technologies. But you can have certain vendor lock-in, like if you choose to go for a data governance or data catalog solution where you have to put all the metadata into that instead of putting it into BigQuery, then it becomes hard to migrate away from it. So try to have your at least the data and metadata centralized within one system so that you don't depend on which other tool is consuming or producing it. Then enable the people and processes. So as we mentioned, don't just rely and think a tool will solve it, but think of your organizational change as well. And then, of course, leverage the expertise of a trusted partner like us to help you in this entire journey. All right, so then let's hear how Antonio actually did it at Deliverect.
Thank you, Sven. So I'll try to give a bit of the unicorn perspective of how we implemented the Google Cloud. In opposition to the previous talk, we didn't have legacy, so the challenges, I think, are a bit different. I think I was already been introduced. I've been with Deliverect almost since the beginning of the cloud journey, so I went through the first adoption of the first services in the Google Cloud to then these more mature data projects using also the Google Cloud services. So I'll start just with a video to introduce Deliverect for the ones that haven't heard about it. After introducing our brands to an ever-growing market, Deliverect helped us manage these brands efficiently and effectively without our need to limit on our creativity.
And being integrated allowed us to streamline this process, introduce brands much faster, and become more efficient.
Managing more than 50 brands with 6 aggregators and more than 400 tablets was a challenge.
Deliverect also helped us make drastic developmental changes to our brands on all aggregators at the exact same time.
Deliverect also helped us to reduce 2 to 3 minutes from our overall in-kitchen time and improve our delivery time by creating this customer-to-kitchen direct order transmission.
They also assisted us in menu engineering. This better helped us understand the impact of the changes we made so that we can better make decisions in the future to cater to our customers.
We had the chance to get our team focused on the other operational aspects and in the customer experience.
We're currently operating more than 50 virtual brands across Kuwait, Dubai, and Qatar, working with over 6 aggregators in more than 20 cloud kitchens, and being integrated with Deliverect allowed us to achieve this in a short period of time.
So yeah, food tech, and we're now expanding to different services. And a bit of how we grew, that plays out also with our cloud journey, is that the company was started in 2018, and then eventually we kept growing. And this slide, for the ones that were here last year, is actually was presented by our CTO Jan, and I just adapted with the news from 2023, which we crossed the 300 million orders mile. And we just got a new acquisition that we are also integrating. Next up, I'll try to go a bit on our journey through the cloud and say that we started with just a single virtual machine, containerized, but everything was on the same virtual machine, also the database. So kind of our first step was to move it away from this virtual machine into a hosted database. From these databases, we then moved to GKE because our services were just expanding. We had a lot of different developers working on different services, so we had the need to adopt GKE to cater for their needs. And eventually we also needed different environments to allow these developers to use different environments and to move faster, because I think this is one of the key differences here, is that we really need to iterate fast and adapt to the market, and to the growth must exist on a scale up, otherwise it won't be a scale up anymore. So this was one of our journeys, and more recently, I think 1.5 years ago, we understood that we needed to take another stance and adopt a modern data stack, because we were using already BigQuery and Looker, but possibly not in the best way. So I'll go a bit on the common challenges that we were facing. This happened because we we had a lot of people developing very quickly, and eventually things start to branch off a lot, and the needs for the data that we had couldn't be met by a central team, because basically the team didn't exist. So these kind of things happened as it sprawled, and then we decided that we really need to do something about it. And what we decided to do about it was to build this modern data warehouse. One thing that we also got caught up in, which I think it's a common thing in startups, is that everyone was working on an urgent mode, so that everything was needed to go very fast, and there was no time to rebuild, and that actually was slowing us down. So this was one of the key benefits and the key sellouts for management, that we really needed to implement such a modern data stack. And how did we do it? We decided that we needed to take a step back and think about how we're going to do it, and also what were the challenges that we were facing at the moment. One of the challenges that I already mentioned was that the knowledge was very spread, and no one really understood end to end. And another thing was the way that people were collaborating was really not effective. We had people building code, we had people working in sheets, we had people just working in Looker, but not communicating with other people. So we understood that we really needed to change this collaboration, and this was introduced by a common code base, and by the separated environments, not only that we already doing for the code base, but we also needed the separate environments for the data processes that we had in place. Some of these we worked with Devoteam on achieving some of these architectural changes. And the journey that we took was a bit like this. And we're now not only connecting directly BigQuery to Looker without central management, but now we have everyone working on dbt, supervising the transformation from these base tables with the reverse ETL that Sven mentioned. We're using different tools. Unfortunately for us, it was not possible to use a single tool for all the services that we are using, as we're using multiple SaaS tools. But then on this transformation, afterwards, everyone reviews each one's code from base to transform to curated, and then there's a lot of now data reusability when it comes to our curated warehouse. We're powering now the BI, which our main tool is Looker, but we're also doing it for other internal tools, using, for example, the CRM services. We're now, most of our teams have a much higher understanding of the data of the company, which at certain stages this was not possible. And also we're now using it as well for customer-facing products, and this is something that we're also planning to do a bit more in the future. So the outcome of this solution was really, I think the easiest to explain is that these questions that I presented on the previous slide stop. So now people just don't even care what is happening, because simply when they want to search for data, they simply find it, and they find it reliably. So this was quite one of the biggest success criteria for us. And as a bonus, we also got that we can now focus on more meaningful work. So not only the teams don't have to be constantly firefighting for problems that could be avoided, but now they're starting thinking, oh, what are the next steps? And these next steps are things that are very important for us to sustain this growth, because at the small scale, we just need to iterate very quickly, but at the scale-up stage, we already need to start thinking on how we're gonna keep scaling, but with a bit more structure, because we're expanding to multiple markets, and just everyone doing everything as fast as they can will not work at this stage. This is actually interesting because we took a iterative approach in which we kept moving new things to the new warehouse while discontinuing the old warehouse. Altogether, I think the project was 1.5 years. I think after 3 months, we already had people on the new warehouse, and we just got access to the old warehouse actually the past week. So this is something that got us happy and makes sense for us to show. Also, some metrics on the benefits of how to actually display on numbers what were the outcomes is that, for example, that the amount of queries from our dashboards that take less than 4 seconds is now almost doubled, and the amount of queries that take more than 300 seconds. Let's say that if a query takes 300 seconds, no one will wait for it because it's just too slow. Now, it was a significant number. I think it's 3% or a bit. We'd reached 3%, and now in the new warehouse, we barely see any queries that take 3%. Biggest thing here is the way that the time we spend in building our new data models on this architecture, and this allows us to now display data fast. Yeah. So what are we currently working on now? I think this plays well with what Sven was saying. I think we need to focus more on data security, because increasing scale will increase the amount of accountability that we have. We are focused on data quality, because even though now things work, there's still problems, and we need to automate this kind of data quality auditing. We're focusing on governance to kind of make it easier for everyone to understand where data is, because this is also one downside of growth, that once we are adding new data tables and new use cases every month, let's say, or even sometimes maybe every week, people are very confused on which data do we have, what is possible, where are things going. So data governance for us will play a big part on our next challenges. And with governance, I mean things like having good documentation and also good discoverability of this data, either via documents or actually just enriching the tools that we have with information on what the data actually means. And a new thing that this warehouse also allows us for is a much smoother integration of our new acquisition, and because otherwise in the previous architecture we would end up with a new dashboarding tool with a new database that if we do more acquisitions in the future, it would be impossible to manage down the line. So what's next for us? Is machine learning on one side, but I think the most important part is that the team is quite excited that they now have time to think about what is the next step. So machine learning is one of those things, but we also are thinking on self-serving data so that the BI team completely gets out of the equation of having to produce dashboards or analysis, analysis they should be producing, but more insightful analysis and not just building dashboards. We're looking for machine learning, just as I mentioned. We started playing around with Vertex AI, and we're also looking at real-time data nowadays, because we needed to move the warehouse iteratively. We assessed the requirements. Real-time was not one of them, but now that things are working, people are starting to make questions of, can we have it real-time? So this is something that we're also excited to be working on in the future. So I think that this is quite a short presentation, but what I wanted to stress out from our journey on this adoption was that our main focus was always to keep moving fast and keep delivering the value. And that's how we took the whole migration. As anything that would be built new would be built on the new warehouse, and we needed to have time to think about how the architecture went, but not that much. Maybe for some of our approaches, we would even do mistakes, roll back, and this was what made it possible for this project to be successful. And I think for our startup as well, is like mistakes are really part of the process, and the quicker you rebound from mistakes, the decisions, the more agile you can become. I guess this was a bit of what I had to present. Not sure if anyone has any questions, either from me or for Sven.
I had a question on the data pipeline you presented, all the way on the right, not this one, but the one from Sven. The one all the way on the right, you have the reverse ETL process, where you mentioned you could use, I think it was some third-party solutions like Census. Are there any Google Cloud native solutions, similar to how the data ingestion has some cloud native options?
So you definitely have, for example, So you definitely have, for example, Google Cloud Data Fusion. And Google Cloud Data Fusion has many different sources and connectors that allow you to, basically get data from, for example, BigQuery into applications, where, for example, Salesforce, etc., are also connectors. And they also, Data Fusion is actually also pretty friendly for end users, as in that it's also a bit of a drag and drop solution. But usually we see that for example, high touch or census is really more also for, let's say, marketing users, where they can create their segments and say, okay, I want to create a segment of those female adult buyers, for example, in really a very easy console, so that they can create this, what is called like a composable CDP, that you don't have a CDP solution and a data warehouse solution where you don't really know, okay, what is a single source of truth, but that you actually use your data warehouse as your center of your data, and then use something like high touch or census to also have this capability of a CDP. That makes sense, yeah. Cool. Any other questions for me or Antonio? All right, then I'll give it back to you.
So for Antonio, there was one slide where you said it was easy to ingest data sources. Can you quantify that? Is that in minutes, in hours, in days, and how quick?
Is this one? Yeah. So the ingestion for us let me first clarify the question. So it is how much time does it take for our ingestion to?
No, let's say someone comes up to you saying, today there's a data source, it's on a MySQL server somewhere. How quick can you get it in the data lake?
So we mostly work on weekly sprints, and if we find that this data is required, we probably would take 1 week. So if we would say urgent, we would plan it in the next week's sprint. So one week. Actually, the bottleneck is at the moment is mostly that people still prefer, or depending on the people, there's quite a lot that just for them data is a dashboard, and the dashboard building is actually the part that takes the longest.
Thank you.
Thank you for Antonio. You were mentioning LCA also among the data that you provide. Are you providing this information to final consumer as well, or it's only business to business that you work?
Yeah, for us, I think that I'm not sure what exactly was on the side, but end customers for us is businesses. We're now also moving a bit more into the end consumer space, like with Chatfit is a company that provides services to end users. But at the moment, we don't have data services to end consumers. It's mostly for businesses.